Hello and welcome. In today's video, we're going to be solving systems of equations using the addition method, or you can call it the elimination method. And we're going to be going over 5 examples that are increasing in difficulty. So without further ado, let's get it. All right, so looking at example number 1, the basic principle of the addition method is we want to eliminate one of the variables by addition and some like equation manipulation and stuff like that. So in this case, it makes it a little bit easier because we have a positive 2y and a negative 2y. And what we're going to be doing is adding the equations together to eliminate one. So those will eliminate when we add this together. So let's go ahead and do that. So we are adding both of these equations. 3x plus 5x is 8x. 2y minus 2y cancels, and that is going to be equal to 16. And now we divide by 8 because we want to solve for x, and then we get x is equal to 2. Now we have our x value. All we have to do is plug this x into any one of those equations there, whichever one, it doesn't matter. You're going to get the same answer. So let's go ahead and plug it into the first one. So we have 3, and our x value is 2, like that. And we got plus 2y is equal to 20. Okay, so now we just solve. So we got 6 plus 2y is equal to 20. And we want to subtract 6 from both sides. We get 2y is equal to 14. And now we divide by 2. And what we get here is y is equal to 7. And we have our x and our y. A lot of times they want you to write it in this form here, pretty much the point form. So we'll put 2 comma 7. And that is our final answer. Example number 2. So when we are looking at this here, what we want to do is eliminate one of the variables. That's what this whole method is about. And when I'm looking at this equation, I'm trying to look at what variable is going to be the easiest one to eliminate. And if I'm looking at the x values here, those look pretty easy to eliminate. The only thing we would have to do is multiply the top equation by 3. That'll give us a positive 6x, and then we can eliminate. So I'm going to go ahead and multiply the entire first equation here by 3. And when we do that, what we are going to get is 6x minus 9y is equal to negative 48. And then we just write down the second equation right under it again. So then we have negative 6x plus 5y is equal to 32. All right, now we can go ahead and add these equations together. So these 6x's here will cancel, and we are going to get negative 4y is equal to negative 16. Okay, and when we solve for y, we'll get negative 4 divided by negative 4. Y is equal to 4. All right, so we found one of our answers here. Now what we have to do is plug this y into any one of those equations. I'm going to plug it into the first one here. So we are going to have 2x minus 3 times y, which is 4. And that is going to be equal to negative 16. So we have 2x minus 12 is equal to negative 16. Add 12 to both sides, like so. We get 2x is equal to negative 4, and divided by 2, divided by 2, x is equal to negative 2. And we just want to write down our final answer using that point form. So we got negative 2 comma 4. And that is our final answer. Example number 3. So when we're looking at these two equations here, we can see that it's not in the form that we're used to. So what we want to do is kind of manipulate the equation a little bit. And what we want are both of the variables, the x and the y, to be on one side and the numbers to be on the other side. So let me go ahead and label these equation 1 and equation 2. And let's start over here on the left-hand side with equation 1. So we have 5x plus 8y minus 22 is equal to 0. And what I want to do is move the 22 over. So I'm going to add 22 to both sides, like that. And what we get is 5x plus 8y is equal to 22. And that's going to be our new equation number 1. All right, so now let's do it for equation number 2. And that is 7x is equal to 6y plus 5. And I want to move the 6y over, so I'm going to subtract 6y from both sides. And what we get is 7x minus 6y is equal to 5. And that's our new equation number 2. So I'm going to take those and I'm going to write them again over here on the right. So our equation 1 is 5x plus 8y is equal to 22. And equation number 2 is 7x minus 6y is equal to 5. All right, so now the equations are in the form that we're used to, and we still want to cancel one of the variables. So in this case, I want to cancel these x's here. And the way we do that is by pretty much finding the lowest common multiple between the numbers there. And in this case, it's going to be 35. So what we want to do is pretty much multiply the first equation by -7 and the second equation by 5. That way, both of those the numbers in front of the x's will be 75. And in equation number 1 here, the -7 will make that a -35x, and we can cancel from there. So let's go ahead and do the math here. So equation number 1 will now become -35x minus 56y is equal to -154. And yes, I used a calculator there. The second equation is going to be 35x minus 30y is equal to 25. Alrighty, so let's go ahead and add these. So these x terms here are going to cancel. And then what we are left with is -86y is equal to -129. And now we divide -86 from both sides. And then you'd use your calculator here. And you are going to get y is equal to 3 over 2. Or you can even write down 1.5, whichever one you prefer. Okay, so that is the first part. Now let's go on to the second part here, and we're going to need a new screen. Y is equal to 3 over 2. And I'm going to go ahead and plug this into, let's see here. Let's do equation number 2. Why not? So we have 7x is equal to 6 times our y value, which is 3 over 2. And that is plus 5, like so. So we got 7x is equal to, this will be 9 plus 5. So we have 7x is equal to 14. You divide by 7, both sides. Then you get x is equal to 2. So our final answer in the point form is 2 comma 3 over 2. And that is our final answer. Example number 4. So we have these two equations here, and what I want to do is eliminate the x's. So I'm going to multiply the bottom equation by 3. And let's rewrite these here. So we got 6x minus 3y is equal to 7. And then the bottom equation becomes negative 6x plus 3y is equal to negative 9. All right, and when we do that, what we see here is that the x's cancel and the y's cancel. So we get 0 is equal to negative 2. And what this means is that pretty much the equation is false. So we have an inconsistent system. Inconsistent system here. Therefore, there is no solution to this problem. And just to get a better idea of what this actually means, let's look at a couple graphs. All right, so here are a couple of graphs. If we're looking at the top set of equations here, this was the example that we just did where it was inconsistent. And we can visually see what's going on here. These lines are parallel with each other, which means they never cross. And the whole point of solving these problems is to figure out where the two lines cross, and that is our solution point that we are trying to find. So the bottom set of equations here, this was from example number 3. And we can see here that the two lines cross each other right over here at the solution point that we found earlier, which was 2 comma 1.5. Therefore, the answer to our problem here is no solution, and this problem is complete. Example number 5. So as we're looking at these equations here, we see that there are fractions, and to be honest, nobody likes a fraction. So what we want to do is try to get rid of those. And I'm just going to go ahead and label the top one equation number 1, and the second one is going to be equation number 2. So let's get started with equation number 1. The way we eliminate these fractions here is by finding the LCM. And what we do is we'll write down both of our denominators here, and then we just start going in multiples of each of those numbers until the first number that they have in common will stop. So 4 times 1 is 4, 4 times 2 is 8, and then you get 12. And with the 3's, you get 3, 6, 9, and 12. So as you see here, the first number they have in common is 12. So that means we're going to multiply equation 1 by this LCM here. Okay, so let's go ahead and do that. I'm just going to write equation number 1 again. So we have 12 times the entire equation, 5/4 x plus a 1/3 y is equal to 3. Okay, and then we're going to distribute the 12 into every number that is within the parentheses. And when we do that, we get 12 times 5 over 4x plus 12 times 1 over 3y is equal to 12 times 3. And when we do these, we can simplify a little bit more. So 4 will become a 1, 12 will become a 3, and then next to the y's, we'll have this 12 become a 4. When you simplify, this will become a 1. And now let's go ahead and polish this off here. We get 3 times 5 is 15x plus 4 times y is 4y, and then 12 times 3 is 36. So this is going to be our new equation number 1. And then let's go ahead and do equation number 2 on the next slide. Okay, so we're looking at equation number 2, and it's going to be the same concept here. We want to find the LCM between the two denominators here, which in this case are 8 and 6. And then let's go ahead with the multiples of 8. So we got 8, 16, and 24. And for 6, we got 6, 12, 18, and 24. So here we see that we have 24 in common. So we're going to multiply 24 to the entire equation 2 here. So let's do that. So equation number 2, we have 24 times the entire thing. So 3/8 x minus 5/6 y is equal to 13 over 2. And now we are going to distribute the 24 into everything. So we will get 24 times 3 over 8x minus 24 times 5 over 6y is equal to 24 times 13 over 2. All right, so now what we want to do is simplify. So 24 divided by 8 is going to give us 3. So this reduces to 3. This goes to 1. 24 divided by 6 is going to give us 4. And that's going to be 1. And 24 times 3 halves. So this 2 becomes a 1. And this 24 becomes a 12. Like so. All right, so now let's go ahead and simplify this. So our new equation number 2 is going to be 9x minus 20y is equal to 156 here. Okay, so now we simplified both of those equations. Let's go on to the next slide and finish this up. So now that we have our equation simplified, what we want to do is try to eliminate one of the variables. And when we're looking at this, we can eliminate the y's here by multiplying equation 1 by 5. So let's go ahead and multiply the top equation by 5, and let's see what we come up with. So 5 times 15 is going to give us 75, then x. 5 times 4y is plus 20y. And 5 times 36 is going to give us 180. Don't worry, you can use your calculator. That's what I did here. And now we're just going to write down the second equation. 9x minus 20y is equal to 156. Just like that. And when you add these together, you are going to get 84x. The y's cancel. And that is equal to, plug this into the calculator here, 336. All right, now we want to isolate x. The way we do that is by dividing by 84, divide by 84, and then we will get x is equal to 4. Okay? Now we have one of our points here, and we are going to go ahead and plug this into equation number 1 so we can find our y value. So we are going to get 15 times 4 plus 4y is equal to 36. All right, 15 times 4 is 60 plus 4y is equal to 36. And we are going to subtract 60 from both sides. And I'm going to go ahead and move this over here. When you subtract 60, you get 4y is equal to negative 24. Divide 4 from both sides. And then what you get is y is equal to negative 6. All right. Now, the last step is to write this in the point solution form here. So we have our answer, which is 4 comma negative 6. And this problem is now complete.